Okay, you want to look at the homework for this multiple regression, the Jack and Jill, or which one you
Yeah,
want
so
to?
Jack and Jill regression assignment.
Okay, let me be sure which one I'm looking at. I'm going to
Jack Jill. Right?
okay, I'm going to share screen so that we'll be sure we are on the same page. Okay.
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 Yeah, it's Jack.
Okay. You're talking about this one?
Yeah.
Okay.
And oh, it's so funny. I was trying to scroll on your screen. I forget.
You can't.
The
Okay.
Word document that you saved down.
Okay.
Right.
Okay.
I did part A. I did part 1,
Okay.
A, B, and C, but 2, I'm not sure. It looks like on the document, the Word document, that you saved the answers again. It looks that way.
Okay. All right. So let me get the work document because, well, I mean, I received those emails from you saying you cannot read this SAV file.
Yes.
The
What is
SAV
that?
file is actually the original data from which the work document is created. The SAV file is an SPSS file. And because I know we're not running SPSS in this class, I say I do the SPSS run myself, and then I create MS Word files. So I'm going to upload MS. I'm going to download the Word file, which is actually the solution to the problem. Your job here is to interpret it. And so in order to interpret it, we have to go through knowing how to test the hypothesis in multiple regression. So, but I will pull out the file, look at the problem, and explain to you how to use the MS Word file once you know how to do hypothesis testing for multiple regression. And once you know how to set up the multiple regression model. But I'll pull it up first, and then we'll go through the process.
Okay, thank you.
Just a minute, it's coming. Okay. Are you seeing the MS Word file? Are you still in Blackboard?
I'm seeing Blackboard.
All right. Okay.
It's probably transitioning.
No, it's not transitioning. It's just, I mean, I'm learning something about the way this system works.
Oh.
So now you are seeing the MS Word file?
Yes.
All right.
So I did 1,
Okay.
in 2, and then I think I did the other one.
Okay. So here we say, prepare a summary table. So this is the summary table. Okay. And then essentially what I did is to ask you to actually do a chart of this summary table. This is okay. If you had to run the SPSS, then you would have had to create this summary table yourself. But I did create it.
Right.
Okay. So this is a summary table. Then ask you to do a chart from it. Which case you plot the mean that compares Apple Valley to Eastview for the average age of the houses. And then you compare the average living space in the two places on a chart. Okay. So Now, so is there a significant relationship between the price of a house and the amount of living space, the age of the house, and the number of bedrooms? Okay, so now this is where you do hypothesis testing. So what I did was I stated the model for you, okay, and the null hypothesis. For example, what you now have to do is to see this model here, which I set up for you there. Okay. The constant is 12,587, which is this.
Right.
Okay. And then the living space. So that is to say, for each additional inch of living space, the price of the house will increase by $36. Okay. So this is what this means, and this is why you see it here. So the price of the house can be estimated by 12,587 plus 36.871 times the amount of living space in square feet. And so that means that for each additional 1 square foot of living space, the price of the house will increase by $36. Okay. Now, older houses, the older the houses, the less the price of the house. Okay, at least for this particular sample of houses, it may not be the same everywhere. Okay, so for older houses, the older the house, and so for each additional year in the age of the house, the price of the house would decrease by 1268.971. Okay, that is the interpretation. And then the number of bedrooms, okay? For each additional bedroom, the price of the house would increase by 5,882, all right? And how many cars can fit in the garage, okay? For a garage, for each additional garage space for a car, the price of the house would increase by 19,282. This is what it says. Now, the question then becomes, are these estimates, do they indicate a significant relationship? Okay, and so, all right. Now, these are the T statistics below. So these are the calculated T statistics that you're going to use to test your hypothesis. All right. And so I provided you the Z star. And so the conclusion here is for the size of the house, the Z star is 2.17. The critical Z star is 2.17. And so our decision rule that if Z is greater than Z star, you reject the null hypothesis. The null hypothesis is that B, which is these numbers here, these numbers are these numbers that indicate the relationship between each independent variable and the dependent variable. So we're going to go through that, okay? So for example, we are saying that the relationship between size, which is an independent variable, and the price of a house is that for each additional square foot, the price of the house will increase by 36.871. But it may be also that when we do the statistical test, we find out that there is no significant relationship between size and price. And so we use the T statistic in bracket that is calculated here to test against the critical value of 2.17 and then decide whether B is equal to 0. If B is 0, then there is no significant relationship between that independent variable and the dependent variable. Okay? And we test each one separately. Each one is tested separately. We test this one separately. We test the slope for age separately. We test the slope for number of bedrooms separately. And we test for the slope for the number of cars that can fit in the garage separately. Okay? All right. So, and if any of them that we are not able to reject the null hypothesis that it is 0, then we're saying that that variable has no significant impact on price of a house. You get the point?
Yeah.
Okay.
Yeah.
So now we are testing at 0.015 level of significance, or 1.5%, and the critical Z value is 2.17. So we compare each of these calculated Z values against the critical Z value. So if Z is greater than the critical Z value, then we reject the null hypothesis that P is equal to 0. We reject the null hypothesis that that particular independent variable has no significant effect on the dependent variable. Okay, and once we reject that null hypothesis, then we conclude that that particular independent variable does have a significant effect.
Got it.
Okay, so this is the first example. So since Z is 10.89, it is greater than the critical Z of 2.17. Therefore, we reject the null hypothesis that B is 0. And once you reject the null hypothesis, what do? You conclude that the alternate hypothesis is that the alternate hypothesis is true. You get it?
Got it.
Which is to say that that means that the size of the house has a significant effect on the price.
Okay.
And so this is why I said, now apply the lesson learned from this example to test the other coefficients.
Okay.
You get it?
Yes.
Okay. All right. So,
Take that information and apply it to number 3.
So that particular process applies to number 3,
Okay.
where it says use the lessons learned in question 2 to answer this question. Okay. And so we are looking at living space. We are looking at age. We're looking at number of bedrooms. This is a whole different, what do you call it? It's a whole different problem.
Whole different data that's represented.
Yeah. Okay, so this is looking at price per square foot. You get the idea?
Yeah.
Price per square foot. The other one is total price, right? For example, suppose you buy a house that is $90,000, right? And the house has 1,000 square feet. Then the price per square foot is 90,000 over 1,000, which means that the price per square foot is $90.
Got it.
So now we want you to test the hypothesis that these same variables have a significant effect on the price per square foot. Okay? I mean, there are some complex interpretations here that you are not yet prepared for, but you can see here that the signs of the variables are different, but you can still interpret what they mean intuitively. For example, there is a negative relationship. Our estimate is that there's a negative relationship between price per square foot and the amount of living space. Okay. Now, for somebody like me who's a trained professional, when I get this result, I will change the model. That's what I will do. Okay. There's an implication that you haven't got to yet. Okay. I'm an econometrician, so once I see that kind of result, then I will change the mathematical form of the model. It will become more complex. Okay, it will become a more complex model, a slightly more complex model. In fact, this is not something that creates a big complexity for me. Once I see that, I'm seeing a flag right there. But what I want you to do for this class is to interpret it in a very simple way. Is the relationship positive or is it negative? Is it significant or is it not?
Yeah.
Okay. Now, if I get a big project where I can now twist this model, then I'll call you. Okay. Since you're diligently attending the lectures, and I'll call you and show you how to interpret complex models.
Okay.
I'm gonna have a PhD in it, so you too can. So don't get nervous about it.
Okay.
Yeah, you can handle it, you know. All right. And then finally say you must also explain the coefficient of determination. Essentially, you have gone through the whole class. You don't even need the PowerPoint slides. This is
Well, I
the
looked at the
PowerPoint.
PowerPoint slides already. Normally what I do is when you save down the work, I go through the PowerPoint slides
Okay.
and then I kind of compare, and then I look in the book, and then I wait for our little lecture to see if there's anything else that I may have to ask you. As I said,
Okay.
if you could just explain the homework, because I already started it, and I was like,
Okay.
maybe I should just ask him. So, you know.
Oh no, that's very good. As a matter of fact, you have I'm going to send this recorded lecture to the rest of the class, and that's it. I have nothing more to say. We've already done the class.
Yeah.
All
Yeah.
right. Okay.
Yes.
So I mean, next week we're going to talk about dummy variables.
Okay.
Okay. We're going to talk about dummy variables, and then we'll move into the other topics.
Okay.
All right. You have any other questions?
Nope. I'm good.
That's it. That's we're done then.
Yeah,
Have
I'm
a
gonna
nice
finish the
evening.
homework and post it tonight.
All right. Have a nice evening then.
You too. Thanks, Professor.
All right.